Hello and welcome. My name is George and I'm joined by my colleague Cameron. And in this video, we're going to be giving you an overview of our latest automated laser processing system. This system represents a success story from one of our customers who bought a system from us 2 years ago to engrave these stainless steel tubes, which make up the housing for a ruggedised sensor. The customer requires the sensor housing to be deep engraved by our micrometer 30-watt motor system, taking just under 2 minutes to process, with each tube manually loaded into the chuck of a Rotary 2.5. Demand for the product has increased following their first system installation back in 2022, and the customers asked us to come up with a solution that both incorporates their current system, which is a micrometer 30-watt, and to increase the throughput of the machine whilst reducing the levels of operator interaction. Since the mark time was nearly 2 minutes, the operator did not have enough time to do any other meaningful tasks whilst the laser was processing their part. As such, we decided to increase the number of processing units, i.e. we added another micrometer, and we decided to automate both the loading and unloading of the product from the machines. We also set a requirement for the system to run unattended for 8 hours. The challenge with that being, how do we store both virgin and processed product in a cost-effective manner whilst being easily accessible to the robot? Following some research and several design reviews, we opted for a rotary accumulator table, given the space and size constraints that we had. My colleague Cameron will talk more about it.
So we looked at a number of different solutions before ultimately deciding on a rotary table. This can hold hundreds of parts at a time, with the benefit of being able to be switched off when a part has been detected to minimise noise. Another reason why we chose a table is that it allows 2 different heights of parts to be used. One batch might have a cap on the top and the other one might not, and other solutions we found would be too complicated to incorporate the 2 different heights. Rather than the operator standing at the laser machine loading them in one by one, they can simply get hundreds of parts and load them in at one time to the table easily. The table is driven by a central motor and supported by 4 casters underneath. This is running on a metal band to reduce wear, and the top surface is made of stainless steel, and we believe this will last a long time before needing replacement. And now, for the star of the show, the 6-axis Cobot, which handles the loading into the system. Now, with it being a Cobot, if a human was to come into contact with it, it will stop for safety. This one in particular has a 5 kilo end effector, most of which is taken up by the gripper, but the part itself is very light, so we weren't really limited by that aspect. This Cobot has a 5 kilo payload, and we've chosen a parallel gripper for this application with some custom-made jaws to fit the part perfectly and grip it without any slippage. The next hurdle to overcome was how to load the part into the system while still being able to do a full circumferential mark, and this wouldn't be able to be offered by our standard rotary devices, hence why we had to design this custom auto-clamping rotary which fits inside the micrometer. On this device, we have a 10:1 reduction precision rotary stage and a pneumatically actuated tailstock. The work holding is specific to this application, ensuring reliable and repeatable position of the product whilst not compromising the marking area. We have 2 sensors at the top for product identification, and down the bottom here is the Outfeed ramp. When the laser marking process is complete, the door opens and the tailstock retracts, allowing the product to fall down the ramp and into this tube where it enters the Outfeed system, leaving the device ready to accept another part from the robot.
And now for the Outfeed system. As the ejected part travels down the tube, it ends up in this holding area where one by one a pneumatic ram dispenses them into this channel. The channel can hold up to 12 pieces before a sensor positioned right at the end of the blade triggers the trolley loading process, which functions like so. One side of the channel drops down, which is this piece here, bridging the gap between the channel and the trolley surface. The blade then pushes all 12 onto the trolley, clearing the channel, ready for the next 12. Once the blade retracts and the channel side wall is restored, the process will continue. Each machine has a separated outfeed which aids with quality control and part tracing. When the trolley is full, a sensor relays that information to the central controller, preventing any more parts from being processed by the micrometer. Thank you for watching this video. To keep up to date with our latest projects, please visit our website. And if you have a bespoke requirement like this, don't hesitate to get in touch.